Hello to everyone. Now we will go with discussing the transfer function, how to display using MATLAB code. This is the transfer function. I will go with second order transfer function. Second order transfer function. You can see here numerator it is 8, denominator is s square plus 3s plus 8. So we have to give them as coefficients, numerator coefficients, denominator coefficients. In the MATLAB, I am going to take a new script. Now numerator equal to 8, denominator equal to, in the transfer function we have denominator s square plus 3s plus 8, coefficients are s square coefficient 1, s coefficient 3 and constant is 8. So 138. 138 are the denominator coefficients, 1, 3, space 8. Then system equal to TF is the command, numerator, comma, denominator. Now I will try to execute this. Click on the run button. It will just ask for saving. You can see here in the command window s square plus numerator is 8, denominator is s square plus 3s plus 8. I will go with another transfer function. 2 by s square plus 4s plus 2. Here eta value greater than 1, overdamped system. 2 by s square plus 4s plus 2. Numerator coefficient is 2. Denominator coefficient is 1, 4, 2. Numerator is 2 and the denominator is 1, 4 and 2. Now I will execute. You can see the transfer function obtained in command window, 2 by s square plus 4s plus 2. Next I have 2 by s square plus 4, theta value 0, undamped system. Numerator coefficient is 2. Denominator s term is not present, so we have to use 0, 1, 0, 4. Numerator is 2. Denominator is 104. 104. Now I will execute. You can see the transfer function in command window, 2 by s square plus 4. Now these are second order system. Coming to first order system. First order system, this is an example, 1 by s plus 10. Numerator only 1 coefficient, denominator only 2 coefficient. Numerator is 1, denominator coefficients are 1, 10. Numerator is 1, denominator coefficients 1, 10. Now if we execute 1 by s plus 10, this is the first order transfer function. We have seen how to give the coefficients in different cases. Now I will go with impulse response of first order system. First order transfer function I have, impulse response of first order system. If you execute, it is executing, you will get the graph impulse response for first order system, 1 by s plus 10. This is the graph impulse response of first order system. Now I will try to get the step response, step of numerator comma denominator, and I will plot the same graph, subplot 3 comma 1 comma 1, and then in the second position subplot 3 comma 1 comma 2. I am plotting step response. Now ramp response, subplot 3 comma 1 comma 3. In the third place I will plot the ramp response. For that, s equal to transfer function, I am taking a parameter s, then I am doing step response of system by s. This will give the ramp response. So first one impulse response, second is step response, third is ramp response for first order system. If you execute, you can see 3 graphs in a single window. So 3 graphs we obtained in a single window, impulse response, step response, ramp response. If you give X label, Y label and title, the third one you can name it as ramp response. So presently we have not given X label, Y label, title. It is coming like this. Now I will go with any second order system and plot same impulse step response like that. I am taking underdamped system, eta value 0 to 1, underdamped system. Coefficients are 8, numerator coefficient, denominator is 138, 8, 138. Numerator is 8, denominator is 1 space 3 space 8. Now if I execute second order underdamped system, step response, first one is impulse response, step response and ramp response, we will be able to see. See the underdamped system step response, it is going increasing above the dotted line 1, then it is settling down with respect to the dotted line. If you properly fix the x-axis with proper delays, you can see the dampings also. This is about underdamped system. Now what I will do, I will plot in the second order system undamped, underdamped, critically damped and overdamped. So now numerator 1, denominator 1 I am taking, and then this is system 1, which will take numerator 1, denominator 1. Okay. Now what I will do, subplot 4, 1, 1, and I am going to take step response. Okay. First case, it is eta equal to 0 and it is called undamped system. Undamped system. Now what I will do, I will copy paste the same 3 more times. Copy, paste, paste, paste 3 more times. So first case is undamped system. Second one is 0 to 1 eta value, which is called underdamped system. Next is eta value 1, which is called critically damped system. Next is eta value greater than 1, which is called overdamped system. Overdamped system. And I will name them in the second case numerator 2, denominator 2, and then this is system 2, and then here I am taking numerator 2, denominator 2. In the second position, I am plotting underdamped system step response. Next, here I have to take in the step response numerator 1, denominator 1 for undamped system, numerator 2, denominator 2 for underdamped system. Next is critically damped system. Critically damped, I am giving name numerator 3, denominator 3, and inside the system also it is 3 and 3, and system 3. This is system 3, and then in the step response, third position, I am plotting critically damped system step response using numerator 3 and denominator 3. Now I will use numerator 4, denominator 4, and which is system 4, and then using numerator 4 and denominator 4, and in the fourth position, subplot fourth position, step response of overdamped system using numerator 4, denominator 4. Now the coefficients I have to change. First one is undamped system. Undamped system. You can see one example for undamped system. This is undamped, eta value 0. Numerator coefficient 2, denominator is 104. 2, 104. Numerator coefficient 2, denominator is 104. This is for undamped system. Next is underdamped system. Underdamped system, the coefficients are, underdamped system coefficients are numerator 8, denominator 138. 8 and 138. Second one 138. It is already present. Now third transfer function. I am going with third transfer function, which is critically damped system. Eta value equal to 1, critically damped system. Numerator coefficient 2, denominator 1 to 1. numerator is 2. In the third case, numerator is 2, denominator is 1 to 1. 1 to 1 are the coefficients. 1 to 1. Critically damped completed. Now I am going with overdamped system. Numerator coefficient 2, denominator 142. 2 and 142. Fourth one, it is 2 and 142. Okay, with this, all the 4 types of systems are available and we should get 4 graphs in a single window. First one undamped, then underdamped, critically damped, overdamped system. I am trying to execute it. You can see first graph is sinusoidal, undamped system, step response. Okay. Second one, underdamped system, step response. You can see graph is going above dotted line and settling down with respect to dotted line. And third one, critically damped system, it is straight away reaching the height. Okay, straight away reaching the height. And this is overdamped system. Overdamped system, it is taking more time to reach the height 1. Okay, more time to reach the height 1. So this is overdamped system. All the four different types of second order system. Step response we have seen as of now. First order system, we have seen impulse, step and ramp response. Second order system underdamped also impulse, step and ramp response. Finally, in second order, undamped, underdamped, critically and overdamped system, step responses we have seen. Thank you.